Our topic is types of roots.
So the first thing you are going to do when finding the type of root is find the discriminant. To find the discriminant, you use the formula, the square root of b squared minus 4ac. So the first one we are going to do is two rational roots. So when solving for two rational roots, your discriminant should be a perfect square and positive. An example of a perfect square would be something like 7 times 7. A number times itself equals a positive number. And if you take the square root of 7 times 7, which is 49, you should get 7. So that's what a perfect square is. And as you can see, it's also positive, which would give you two rational roots.
So for the example, for two rational roots would be 6x squared minus 11x minus 21 equals 0. 6 is going to be your a value, 11 is your b value, and 21 is your c value. And to find the discriminant as said in this formula, b squared minus 4ac, you plug in your a, b, and c values to be negative 11 squared minus 4 times 6 times negative 21. This equals square root of 625. 625 is a perfect square because here, if you do 25 times 25, it equals 625. And then you find the square root of 625, you get 25. So it is a perfect square, and obviously it is a positive number. So the answer has to be two rational roots.
So the second type of root there can be is two irrational roots. Once again, you will find the discriminant using the formula, the square root of b squared minus 4ac. Only this time, it is not a perfect square, but it is positive. So an example of this would be 48. So the square root of 48, when you plug that in, you get a long decimal. So it is not a perfect square, but it is positive. So when you get an answer like this, you will have two irrational roots.
So for the example, for two irrational roots, you get x squared minus 8x plus 4 equals 0. Once again, it's your a value, which is 1. I plugged in the 1 there so you could see it. Then the 8 is your b value and your 4 is your c. And then in the discriminant formula, square root of b squared minus 4ac, you plug in these values according to the formula. Negative 8 squared minus 4 times 1 times 4. This equals to the square root of 48. As Erin shows you, that wasn't a perfect square, so it can't be two rational roots, but it was positive, so it has to be two irrational roots.
So next, once again, you are going to find the discriminant using the same formula you have been using. Only this time, it can solve to be 0. If your discriminant solves to be 0, it is equal to one rational root.
And for example 3, you have 4x squared minus 12x plus 9 equals 0. 4 is your a, 12 is your b, and 9 is your c value. Again, your discriminant formula is b squared minus 4ac. You plug in these and you get negative 12 squared minus 4 times 9. This equals to square root of 0, and every time you get that, it's always going to be one rational root or one solution.
So last, you are going to find the discriminant using the formula, the square root of b squared minus 4ac. And this time, if you solve it to be negative, you will get no solution. So for example, if you take the square root of negative 36, it comes up as an error or a non-real answer. So you will get no solution.
For the example, you have 2x squared minus 9x plus 13 equals 0. And here is your a value, your 2, 9 or negative 9 is your b value, and 13 is your c. You plug this into b squared minus 4ac. So you have negative 9 squared minus 4 times your a, 2, and times your c, 13. This equals to a negative 23. This is a negative number, and that means it is a no solution.
So some other names for the roots are the x-intercepts, zeros, or the solutions. And basically the whole point of finding the discriminant value is getting it from the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. And b squared minus 4ac is where you get the formula for the discriminant.